Question 2 for discussion 6, Boolean logic. In digital electronics, it is often important to get certain outputs based on your inputs, as laid out by a truth table. Truth tables map directly to Boolean expressions, and Boolean expressions map directly to logic gates. However, in order to minimize the number of logic gates needed to implement a circuit, it is often useful to simplify long Boolean expressions. So over here, we have the 9 key laws of Boolean algebra. When doing Boolean algebra, Boolean addition corresponds to the logical function OR, and Boolean multiplication corresponds to the logical function of AND. 2.1. Use multiple iterations of De Morgan's law to prove the identity not A or A and B is equal to not A or B. Over here, we can see De Morgan's law of the AND form is not A and B is equal to not A or not B. De Morgan's law of the OR form is not A or B is equal to not A and not B. So on the left-hand side, let's start off with this equation. Not A plus AB. Then we're going to use De Morgan's law in the AND form. And so this, if we treat this component as the B over here, and this component, not A, as the not A over here, then we're going to end up with not A, so it's going to be not A, and then we're going to, for the B over here, this B is negated compared to the not B, so we're going to negate this expression. So it's going to be not AB. Then we're going to use De Morgan's law again for the AND form to separate out this component. So directly you can see that not AB is equal to not A plus not B. So it's going to be A times not A plus not B. Then we can multiply out the expression with the distributive property. So we're going to do this all under the naught. So it's going to be A times not A plus A times not B. From the inverse law, we can see that A times not A is going to be equal to 0. So that means we're just left with A times not B. And then again, we can use the De Morgan's law for the AND form, where the A is going to be the same A as this one, and then we're going to use not B for this B. So then it's going to be equal to not A plus B. And so that's how you get from not A plus AB is equal to not A plus B. 2.2. Simplify the following Boolean expressions. Part A. A or B and A or not B and C. So if we multiply this out using the distributive property, A plus B times A plus C is A plus BC. It's going to be A plus BB, all of that times C. And then we know that B times not B is going to be equal to 0. So we have AC. Part B. Not A and not B and not C, or not A and B and not C, or A and B and not C, or A and not B and not C, or A and B and C, or A and not B and C. So this is going to be equal to not A, not C, times not B plus B, plus A times not C, plus times B plus not B, plus AC times B plus not B. And the way to get this is you can separate everything out in terms of not B plus B. So over here, you have A, not C, and not A, not C, and then you can factor this out, and then you're left with not B plus B. Similarly, you can do that with this B and not B, and then you get A and not C, so A and not C times B plus not B. And for the last one, you get AC and B and not B. So you get AC, B, and not B. This is going to be equal to not A, not C, plus A, not C, plus AC, because not B plus B is going to be equal to 1, based on the inverse law of the OR form over here. And this is going to be equal to not A, not C, plus A, not C, plus A, not C, plus AC. And the reason why you get A times not C plus A times not C is because A plus A is equal to A. Then you can factor out not A plus A. So you get not A plus A times not C plus A not C plus C. So this part corresponds to that, and this part corresponds to that. And last but not least, since you know that not A plus A is just 1, you're going to get C plus A, because not C plus C is also 1. So this is the simplified expression. Part C, we're going to simplify this expression. So for this expression, the first thing we're going to do is use De Morgan's law in the AND form. So this is De Morgan's law in the AND form. I'm going to write it down here for clarification. So for that law, it's going to be not AB is equal to not A plus not B. So in our case, this A is going to correspond to this, and this whole expression is going to correspond to this B. So when this is simplified out, this will become not A plus not B, not C plus BC. This is going to be equal to not A plus, and once again, we're going to use De Morgan's law to separate this out, this time of the OR form. So I'm going to write the law down here. That's going to be equal to not A plus B is equal to not A times not B. So for our expression over here, this is going to correspond to this A, and this is going to correspond to this B. So then our expression will end up being not B, not C, times B, not BC. And then we're going to use De Morgan's law again for each of these expressions, for this expression and this expression. So for this, we're going to treat not B and not C as this and this. So this is going to equal to not A plus B plus C. Then we're going to treat this as A and this as C. So this is going to be equal to not B plus not C. Then we're going to simplify this. Not A plus B, not B plus B, not C, plus C, not B plus C, not C. And this is all equal to 0 according to this law. So we're going to end up with a not A plus B, not C, plus C, not B. Part D. First, let's multiply out this expression. So we're going to get not A plus not AB plus B plus A plus B. this is going to be equal to not AB. This can be canceled out because we know that not AA is going to be equal to 0. And similarly, we know that AA is going to be equal to A. AA is going to be equal to A. So this just converts to A. So we get B plus A and A plus not B, because this is not B. That was my mistake. I miswrote in the beginning. Next, we're going to multiply out this expression. So this is going to be equal to not AB plus BA plus B not B plus AA plus A not B. This is going to be equal to A. This is going to be equal to 0. So we're left with not AB plus BA plus A plus A not B. Then let's combine these two together. So we get equal to not AB plus A, and then we're going to combine BA and A not B. So we're going to get plus A B plus not B. And we know that B plus not B is going to be equal to 1 because of the inverse law of OR form. So this is going to be equal to not AB plus A. And we know that A plus A is equal to A according to the idempotent law of the OR form. So this is going to be not AB plus A. And this is going to be equal to A plus B. So this comes from the identity we proved in 2.1. And a more intuitive way of thinking about this is also due to the fact that, say A is equal to 1. If A is equal to 1, this expression would already be true because of this A over here. On the other hand, if A is equal to 0, then this would not be true, right? So it will depend on whether this expression is true or not, because the plus stands for OR. So then not A would be 1, and what we're depending on is whether B is 1 or not. So if B is 1, then this expression will be 1. But if B is 0, then this expression will be 0. So this is why when you have an expression like not A, B plus A, this can be evaluated into A plus B. Thank you.